How much longer you got on that?
Not too much.
You just having a good time doing that.
A couple hours here and a few hours there. Hopefully my door comes in possibly tomorrow, but maybe Friday. More likely Friday.
Well, I noticed all of our.
Frank T, you built that house up on Pine Crest?
I did two up there.
Right there.
Yeah, I did two up there.
And, here's what, like, when he told me how much he paid to have that house built, I said, man, you had a deal.
It may be, it may be a time.
But that was, what, about, when did you start that? About 8 years ago?
Maybe.
That was a different time.
Yeah, but still, he got held still.
He could not, he couldn't get anything done. What do you?
He couldn't.
Okay, John, let's go ahead and get started.
It does. You stayed the Holiday Inn Express last night. Hello, Mr. Harris.
How you doing, sir?
Good. You good to see you.
I didn't get anything. I didn't get any. By email.
I didn't read that one you sent. Yeah,
What's that?
I didn't read it. Yeah.
I went through it.
So that's what Jordan and I said, I've never.
But it's good.
I know, but I've never.
I mean, I understand, I understand those things.
But the rest of it, that's what I said, why did Jeff want us to read it?
I wanted a copy of it, so that. Copy of it.
Oh, I got it.
Sorry, guys.
Oh, okay. I just said, couldn't have it.
Yes.
I would have, like, you.
And I didn't know what this.
Amy, how'd you swing the full end of the table here?
I don't know, I guess y'all invited. After all these years, y'all.
Just don't tell anyone what happened.
Let me call to order the special Board of Commissioners meeting for April the 8th, 2025. The purpose of this meeting is to have a preliminary engineering report presentation for the Mirror Lake dredging project. Let me just give some background and some people that I've asked to join us today. Pat Gleason and Mike King are here from the Mirror Lake Improvement Association. And then we have our Board of Commissioners here. As you recall, now about 2 years ago, we were awarded a $5 million grant for the purpose of dredging Mirror Lake. I did a lot of working and lobbying with our representatives, Representative Gillespie and Senator Corbin, brought them to the site. And we shared with them the plan that had been developed by the Mirror Lake Improvement Association. I emphasized that this was a very important project for maintaining water quality for our watershed and for our drinking water in the town of Highlands. I want to again express my appreciation for the work that Representative Gillespie and Senator Corbin did, in that when we had the last long biennium budget session, there was a lot of money available from the Inflation Reduction Act, a federal program on water quality and water projects. And I was aware of that and was hoping that they could come through for us. What was amazing was that we were trying to track all the bills that were being passed. We had a request for funding to do upgrades to our water plant, which we received. And at the last minute, and I do mean at the 11th hour, they put that request forward in the budget to fund the Mirror Lake dredging, and lo and behold, it was passed. It was so at the last minute hour. I thought it had not been passed. And then I was made aware of it about 10 o'clock the next morning that in fact that was in the budget. So we have that money, $5 million. The town is the, if you will, the kind of the agency that administers that money because we are a municipality and we have that money in hand and say keeping in our deposits. So we're at that point. And then the next part of that project was that the Improvement Association would start what we call phase one of dredging near the bridge. We've been working closely with Pat Gleason, Mike King, and the people from that organization. And in fact, they have started that project. I saw the excavator there today, and I know the barge will be coming right, or the dredging barge will be coming right behind the excavator. So they've got that phase underway, and we now are looking at the other phases. Part of that process, because we must follow all state procurement contract requirements, everything that state money requires, we had to hire a company to do the engineering study of the project, how this can be done in all the technical specifications and requirements. We hired McGill Associates to do this study several months ago. After board approval, they got to work on the project. I saw a lot of their staff in boats and walking around doing all this analysis and measurement of the lake. So we are at a point now where they have done an engineering report. They sent it to the town about a month ago. Our town manager received it and then asked our Public Works Director, who is a professional engineer, that is a civil engineer, to review that report to see if there's any questions that we might have, clarifications, concerns, or whatever. Lamar Nix took several weeks to do that and found that the report was complete. And we have shared that report with people who have requested it, and we will continue to do so. But what we are here tonight to do is just to help the folks from McGill Engineering to do a presentation on what their findings were. I suspect they'll be wanting us to give them some direction about where to go next with this stage of development of this project. And we'll hear the presentation in just a minute, then followed by questions that the board or the members of the Mirror Lake group would like to ask, and then I'll throw it open to question and answering from anyone in the audience. So at this time, I'd like to introduce from McGill Engineering, Joel Storrow. Yes, and he will start the presentation, and I'm glad to have you with us.
Thanks, Mayor Taylor. Appreciate being here. I'm Joel Storrow. I'm a principal with McGill Associates. I work out of our Asheville office, and Mike Hansen is also with us. He's vice president, works out of our Raleigh office, and he's our expert in water resources. And so he's a perfect fit for this particular job. McGill Associates, we celebrated our 40th year of business last year. Very proud of that. We worked in Western North Carolina for all that time. Done a number of projects up here in Highlands. We water, sewer, some stormwater work that we did years ago. Is it not on? Is it hearing? Oh, sorry.
Yeah.
Hear me now? Okay, great. Sorry about that. But it's been a privilege to work on the Mirror Lake dredging plan. It's been a project I know the town has been dealing with ever since I came up here in the 90s. Y'all were talking about it, but it's all driven by the funding and everything. And I'm certainly pleased to see that y'all have leveraged some of the the earmarks and this IRA money that was available through the state. It really is going to make an impact. Mike's going to go over the nuts and bolts, and we certainly will welcome any questions after he's done.
Thank you, Joel. So we spent the last several months putting together this report. We started our survey in the field just after Labor Day of last year, and spent several months doing a cross-sectional survey of both the existing bottom and the historic bottom. So the dredge, the top of the sediment, the bottom of the sediment, so that we could estimate the total volume of material that needed to be removed. We also did environmental assessments along the entire stretch, both the upper riverine section and the lake section on the lower end. We did a lot of investigation looking at prior studies. We also did coordination with agencies, verify some of the assumptions that we were making as far as how a permitting needed to be approached on the project, what things were going to be particular criteria that the agency is going to be looking for how the spoil was handled and where it could be disposed of. And we also did some coordination with the contractor that is currently involved in phase one. It was an opportunity to get involved with them a little bit to understand how they're approaching phase one, make sure that that was taken into consideration amongst all of the experience and other knowledge that we're bringing to the table on how to go about doing dredging projects and how they should be planned and implemented. So there's, I think there's a lot of things that have gone into where we are today. And today is yet just the beginning. The preliminary engineering report brings forward this information for consideration, brings forward recommendations, which we'll get to at the end of the presentation. And yes, we will be looking to the town to provide us their direction based on the recommendations that we provided. So with that, next slide, please. The existing conditions here I went through in brief detail just previously. I wanted to point out the two slides here. One of the things that was of particular interest to a number of the folks that we were working with in the town were both the water depth and the sediment depth that's currently in the lake system. We found that the water depth ranged from as little as inches in certain areas in the wetland and certain areas in the riverine section, up to about 18 to 20 feet in the open water area of the lake. There are some pockets of significant sediment deposition within the riverine section, the lake section, and the wetland section. And those are shown in the lower image. The hot pink areas that are showing up on that image are showing where a lot of the sediment has accumulated over time. Most of your upper reach in your riverine section currently is at an overall depth of sediment of anywhere from 1 to 4 feet. So if you take that backwards, what was the original lake, what was the original channel depth in that area? Generally 4 to 5 feet of open water is what we expect was the original condition prior to the sedimentation coming in. As we go into the lake section, we have similar areas that are very shallow. You can see just off the bridge, there's an area where there's been a sediment deposition that has actually gotten to a point where it's above water some of the time. Those are areas that when it was originally dredged, likely most of the lake area was at a depth of 20 feet or greater. We found significant areas within the lake system that were suggestive of having depths of 20 feet of open water when the sediment was not there. Again, the sediment deposition in the lake are in the kind of the obvious areas as the water comes down the river, carrying the sediment load. It comes into the lake, and some of that deposition is right as it gets into that open water area. Sediment likes to drop out. A lot of the lighter sediments, the silts get pushed in to this first bend, and they drop out where the energy drops off on the outer edge of the bend. So you end up with some shoaling that's occurring here. And that's causing a narrowing of the open water in that area of the lake. You have very shallow water areas in this section of the lake. We also had areas along the shoreline where we've got deposition of material as the water levels have risen and fallen over the years. So a lot of the docks and other areas that are right up on the shoreline have accumulation of sediments, starting to see some vegetation growth. The most obvious area that we're seeing this is in the wetland area here. This area appears to have been open water when the area was originally, when the lake was originally dammed up. Most of the sedimentation information that we have in that area suggests that that area was still a shallow area, likely 4 feet or less of open water, but it was open water at that time. Over time, sediment has accumulated from storms flowing through the area, being brought into this basin. And as that water drops out into an open area, the sediments have a tendency to drop out in that same area. That's why you're seeing a lot of sedimentation accumulation in this area, especially because it necks back down before it goes into the lake. And that has a tendency to concentrate that sediment dropout in that area. So next slide. We also took a look at utilities. The utilities that we have identified, we talked with the town engineer. We're able to find some information on water lines and sewer lines that will have to be addressed as part of our dredging plan. Some of these cross the open water, particularly the water line coming here near the bridge, another one that's coming across the open channel here, sewer lines that come through the area. So one of the challenges is that we know approximately where they are horizontally. We don't know vertical depth on them because we don't have as-builts. So that'll be part of what we addressed in our contract documents for the contractor. They'll have to come in and locate those specifically before they start doing their dredging activities so that we know that we're going to protect those areas. And we may end up having to adjust dredge depths in those areas depending on where the utility turns out to be, so that we can protect the utility and we don't end up exposing the utility. If it was put in with the intent of being buried, we want to leave it buried. We don't want to expose it to the forces of running water flowing through it and potentially disrupt the joints on the pipe, et cetera. So there's, we'd like to find, better information to go into the documents, but as of right now, that's the information that we have available. We also shared this information with the phase one contractor that's out there now. During our discussions and trying to get more information about exactly how they were approaching their phase one work, I asked if they had these utilities. They did not, so we provided that information to them. So hopefully that will avoid any mishaps with their work, because most of their work is occurring in these areas immediately upstream and downstream of the bridge. So with that, next slide. Okay, so dredging methodology. One of the things that we do when we're asked to produce a dredging plan is we want to gather more information about the characteristics of the water body and the depth of sediments that are there, but also the type of sediment that's there. We want to do some sampling. The type of sediment tells us a lot about how contractors will likely approach the removal of the sediment. Heavy granular sediments like sands are more easily removed with certain methods, and the light, silty, fluffy type muck soils that have a tendency to accumulate in the open water areas are better addressed with different types of methodologies. The phase one contractor is using hydraulic dredging for their work, as far as we know. At least that's the information they shared with us. And that's likely a fairly good approach, being that most of these areas in most of what we found in this area was that these sediments that are in this area are of the lighter silts type materials, and those are better addressed with hydraulic dredge. As you go down into we did sampling at the bottom of the lake near the dam, at the mid-lake area here. We did sampling here in the riverine section, and then up at the top end, we did another sample. We found most of the riverine section, as you would imagine, is granular soils, because a lot of the energy is still moving those lighter soils downstream. As you get into the open water area where you've got greater water depth, a lot of that granular material is dropped out in the river section, and it's carrying those light silts into the open water area. So the bottom area in the lake is predominantly light silts. And that has a lot to say for what we're going to be doing for our recommendations on how to approach this job. We're not going to be dictating to the contractor how they do their work, but we need to estimate the volume of material and the type of material so that we can estimate the cost based on the likely approach that the contractors will take in approaching a job of this type. This here shows some of the sampling information that we did, and we ended up working with a geotechnical engineer to obtain those samples and take them back to their lab, do testing on them, characterize the samples for us. And we'll talk a little bit more about other sampling that they did for us in a moment here. Disposal options. And that's another big issue with dredging. Dredging is the first half of the dredge job is getting the sediments out of the water body. And then what do you do with it once it's out of the water body? How do you handle that material? You've got to somehow take it into a truck, take it into a sedimentation bag. You've got to dewater those sediments, especially in the lake area where you have the lighter colloidal sediments. They like to hold the water, so it takes longer to dewater them. So what we're expecting the likely approach in that section is going to be hydraulic dredging, pumping the material through hoses up onto a land area into bags that are pervious. The material, the silt material will accumulate in the bag, and then through gravity, it'll leach out the water, and the water will return back to the river. All the sediments will be captured in the bag. And we expect that that's going to be a similar operation to what phase one is doing. That's exactly how they're approaching phase one right now. They're working in the area that is, and I'll show it to you on the next slide where we've got the river up again. They're working a small area right along the Coliseum River Drive. That area is suitable for them because they're only moving 5,000 cubic yards of material. And they're doing it in a very, I'll use the word relaxed. They're not approaching it to try and get in and get as much done as quickly as they can. They wanted to come in and try and work their way through in a way that minimized the amount of impacts that they had, minimized the amount of permitting they had, and therefore they were willing to address it in a little bit more of a time-consuming approach. That means they're going to pump the material into the bags, then they're going to let the bags sit and release all that water. Probably not going to have a lot of operations going on while that bag is sitting, releasing water and dewatering. Then they'll come in there, remove the sediments mechanically, load them into a truck, haul them away, bring in a new bag. Then they'll start to pump, and they'll pump the bag full again. And they'll do that in a series of operations over several weeks of time. That's good for when you're trying to move a small amount of material. When we start looking at the amount of material that we need to move out of the lake, we look at the total quantity that we'll be addressing here in a minute. We're dealing with a much bigger operation, and we don't really have the ability to approach it with a relaxed approach of just allowing things to take the time they need to in order to do it in small batches. So we'll talk more about that as we go. As far as the operations are concerned, I'll make a point of comparison. I don't know the exact locations, but they did share with me that they were disposing of the material for phase one in a series of different small areas, both land application and permitted disposal sites. So that means it's a patchwork quilt. And in some cases, they're hauling the material quite a far distance away to be able to find areas that can accept these amounts of sediment on for agricultural use or in a permitted landfill. Again, that's a little bit of a different approach than what we're expecting the contractors will likely do for this project that we're looking at, because we're dealing with about 20 times the volume of material that we need to move. So if we took that approach, we'd be working at this for many, many years. And I didn't think that that was probably a likelihood that the town or the citizens really wanted to contend with. So we tried to reduce the amount of time that's necessary. That means we go at it with a little bit more of a deliberate approach. So we identified 2 specific sites that were available. One here, the old Highlands landfill that is closed and capped at this point. We've had some discussions with the agencies, believe that we can do a temporary reopening of that site to put a limited amount of material on as additional capping material on that landfill. That's good because that location is only I think about an 8 or 9 mile round trip from Mirror Lake. The other alternative is to take it to the Franklin landfill operated by Macon County. That's a 40-mile trip. When we talk about what it costs to do dredging, a lot of the cost is not in getting the material out of the lake. A lot of the cost is how do I get rid of it? The further away I have to haul, the longer distance that those trucks have to go, the more cost there is involved in the job. So this is the nearest facility that can handle the volume of material that we're going to need to deal with. We don't have the liberty of being able to do a patchwork quilt of small farmers and other applications that we can do one-off type applications, or we'll be here for a very long time. So that's the two locations. The additional testing that we're talking about is when we did our initial testing, we went through and we looked at both the sediment size, the grain size, the types of materials that we're dealing with. We also did an evaluation for what we consider to be we call them the RECRA. That's a term related to landfill, but it's typically the pollutants that you'll see in stormwater runoff from roadways, from agricultural areas, from residential areas that bring in, that do application of fertilizers and that type of thing. The types of things that get washed off of your yards and your parking lots and your roadways that end up in your water bodies. We found that there wasn't a lot of material that was what we consider to be pollutants. One of the reasons we're looking for that is that the type of pollutants and the quantity or the density of that material in the dredge material that we're bringing out is directly related to where we can dispose of it. So we needed to go through and make sure that we didn't have any materials that were showing up in a high enough concentration that it was going to force us into going into some type of a limited operation for hazardous materials. And I have dealt with those types of problems in other areas. They're very expensive to deal with. Fortunately, we don't have them here. Most of the upland area or upstream areas in the upper Calisaja River are wooded. We have some development. We have some golf courses. And most of that generation of material is more of the nutrient type materials that you would expect to find. So those are not things that are prohibiting us from being able to dispose of the material. We did find arsenic and a few other elements that made a little bit of concern. We went in and we did a second round of testing to look at volatile organics and a number of other specific chemicals that, when we're talking with the regulators for the landfills, specifically said, if you have this, you can't bring it here. If you can show me you don't have this, you can bring it here. So we went through that second round of testing, and we found that the material was clear from all the things that would prohibit us from disposing of it at either one of these landfills. So that's good news. It allows us to utilize these two nearby sources for disposal and try and reduce the overall cost of the project as we move forward. Next slide. All right, permitting. One of the things that phase one did not do was they dredged a small enough area and they limited the amount of impacts in wetlands so that they didn't have to go through a state permit process. When we go through this process for doing the entire lake, we will have to address that state permit process. So that'll take us more time to move through that, to accumulate the information, prepare the documentation to submit for review, them to go through and review, comment, provide information back to us. And I think it's a good time for us to talk a little bit about the types of permitting that we expect on the job. For the type of permitting that we expect in the lower area, in the lake area, where we expect that the contractors will likely end up using hydraulic dredging approach, we will not have to have an exhaustive amount of permitting. The permitting will be relatively straightforward, partially because the dredging type, the methodology for hydraulic dredging typically is less impactful to the environment. And it's causes less turbidity, so it's easier to control that and not create water pollution problems as part of the dredging activities. So that goes through the agencies relatively quickly. We expect that it's likely going to be about a 3 to 4 month permit process, which is typical of environmental permitting in North Carolina, and working with both the Army Corps as well as DEQ. When we get into the riverine section, hydraulic dredging becomes impractical because we're dealing with much less water. Hydraulic dredging requires a large volume of water to move the material through the pumped pipes. And we're dealing with heavier sediments. So again, more water to move the heavier sediments, larger pumps to move the heavier sediments through the hoses. So then that means that you're likely going to end up doing shorter stretches of pumped material if you do pump it, or you're going to move to like a mechanical dredge. Either one of those introduces more opportunity for impacts in stirring up sediments and turbidity, as well as you can see the green area here are all the wetlands. Around the lake area, the wetlands are relatively limited to the shoreline and very small in their areas. So they're easier to stay away from and not impact if we choose to move in that direction. As we get up in the river section, you can see that, you know, the upper part of the river is pretty difficult to stay away from the wetlands altogether. We're going to have some impacts just to be able to get a narrow channel through there. Again, if that's the option that the town chooses to pursue. In addition, looking through this area through Mill Creek, all of this area is designated wetland. I know at one time it may not have been. As of today, it is. And so we have to contend with how much of this are we going to dredge, how wide are we going to get into, and how much impact are we going to have. And I raised that up as a reason for permitting. It takes longer to go through the mitigation process, the buy down, the turbidity issues that I mentioned. We'll go from a 4-month cycle for permitting likely to something more like a 9-month cycle for permitting. So we'll talk about this a little bit later, but we're recommending that we split the project into phases. That's similar to the approach that was already recommended from the prior study that was done. But we're working based on where the permitting is going to lead us in the direction of what work can we do early versus what work we're going to be doing later, because the permitting pushes us further out. So a little bit different approach as to why we're doing a phased approach, but still falls in line with that prior study. Let's see here. I think that's everything on permitting. Next slide, please. All right. So we get into the options. We tried to look, again, when we look at a dredging plan, we don't want to come up with a single approach and say, this is the way you have to do it. We want to look at the likelihood of contractors bidding this job and the type of approach that they're going to want to use in order to generate the most economical removal of the sediments, because that drives down the cost, obviously, for the town. So the first one we looked at was kind of the maximum extreme. If we went in and we removed all of the sediment accumulation that we found from the river section all the way down to the dam, how much volume of material is there? I said earlier that we did a survey of the top and the bottom, kind of where the sediment is now and where we believe the natural bottom was before. That's the volume of material that we're looking at here, 113,000 cubic yards. Phase 1 is moving 5,000 cubic yards. So you can see the order of magnitude of difference that we're dealing with if we took this approach. We went through and did some cost out calculations based again on the knowledge we have of the project and the likely approaches that will be used upstream, downstream, the approach that the contractor would likely use for handling of the material, the dewatering, and the transport of the material off-site. and disposal of it. And we came up with an estimate that was in excess of $6 million. We all know we've got 5 million to work with. So this plan's probably not a good one to move forward with out of the box. So we looked at another alternative. Next slide, please. This one, what we wanted to do was talk a little bit about, I'm sorry, can you back up that slide one more? Wanted to point out one other thing. This one, removing all the sediments, means that we're also going to go in and we're going to impact all the wetlands that are in the way. So we're going to try and take it back to its historic channel that it was, historic lake area that it was. That means all the wetlands that are up along the periphery of the lake, those are all going to be impacted. All the wetlands that are up in this channel here, all going to be impacted to some degree. So we've assumed with this alternative that we've got 1.3 acres of wetlands impact. That doesn't include the Mill Creek area. I'll talk about that in a minute. When we talk about what do we do for mitigation? Well, mitigation is one of two ways. Once I impact more than 1 acre of wetlands, I have to mitigate for it. That means I buy land somewhere else and I build a new wetland there. Or I buy land that's currently not preserved that is wetland. I buy it, I preserve it in perpetuity as a wetland. Or I pay a check to the state and they use that money to go out and buy wetlands or create wetlands. So it all comes in a full circle, but it does make it a little bit easier for someone who wants to do a project but doesn't want to be the owner of a wetland long-term, is they can do a buy down. The estimate for the quantity of the buy down, we're fairly comfortable with. The value of the buy down is variable. The cost is based on what the agencies determine the quality of the wetland is. And you can have anywhere from a 1-to-1 to a 4-to-1 requirement, depending on the quality of the wetland that is being impacted. We're estimating that most of these wetlands are going to be in the 1-to-1 range. Some might go over into the 2-to-1 range. We're looking at a total dollar value of nearly $77,000 per acre. So the more wetlands we impact, the higher the price goes on the dredge project. And that's not associated with the dredge. It's associated with the wetland impacts. So there's multiple things that we're trying to track as we go through. How do we cost this project out besides just the removal of the material? Now you can go on to the next slide, please. So option 2, how do we reduce that cost? How do we get under the $5 million threshold? One thing we could do would be to go through and preserve all the wetlands. That brings the dredge area in from the shoreline and saves us nearly $120,000, $130,000 based on our prior estimate. So that's good. That moves us in the right direction. Doesn't solve the problem for us, but by bringing in and preserving all of these wetland areas that are in these edged water areas, we also reduce the amount of sediments that we're removing. So that has a downward tick on the total cost for the project, because the less sediment I move, the less I have to handle, the less I have to dispose of. So I get multiple benefits there. We looked at trying to go to what do we preserve all the wetlands, and we dredge only the areas that are not in wetland right now. And again, this excludes the Mill Creek area. That brings us down to nearly 90,000 cubic yards. Brings it down to a cost of 4.6 million. Now we're in the range of what we think we might be able to afford based on the money that's available. We got to remember that, the money that's available is also paying for the engineering study. It's also paying for construction management, a number of other things. So we're not going to have the total 5 million to do just dredging. The other thing is right now we've got a very volatile construction market as far as pricing is concerned. It was very volatile when we were in the pandemic. Coming out of it, tended to settle down a little bit, and now everything's kind of upset. And there's prices that are coming in that are double what was expected 6 months ago on a number of jobs across the state that we're seeing. So we want to be a little conservative with what we think we can afford. And I guess let's go on to the next option. So the next option is what I refer to as 2A. It's a hybrid option. It looks at how do we do the most amount of dredging that we think we can do to remove the most amount of material from the lake and thereby benefit water quality. That was the kind of the primary initiative of why this money came forward to the town to begin with, is to try and benefit that water quality that's going downstream into Lake Sequoia. So with that, we can reduce. Let's look at trying to capture the volume of material throughout the entire area. But when we get into those deeper sections of the lake, maybe we don't go down to 18 feet. Maybe we go down to 14 feet. That leaves sediments at the very bottom of the lake, but they're a lot less likely to get churned up and moved downstream when they're that deep in the lake to begin with. So that's one way of trying to reduce overall volume of material. One of the other benefits is, now I'll talk a little bit about Mill Creek. When we first were brought into this project, it was shared with us that there was an initiative to try and open up Mill Creek to recreation, kayaks, canoes, being able to navigate through the wetland. Right now, there is a channel that goes from the lake all the way up to the culvert underneath Colisaja Drive. But that channel is interrupted by beaver dams and falls and other things. So you'd be hard pressed to get a canoe through that area. It's very narrow in certain areas. You'd be doing an awful lot of dragging the canoe through the wetlands in order to be able to get all the way out to the bottom end. So we looked at trying to go in and identify where we would need to remove those snags, those beaver dams, in order to open up a 5-foot wide channel all the way out. So that's one way of trying to reconnect this area out to the lake. Another way would be to try and make a circular path. There's somewhat of a path that comes in here along Colisaja Drive, and then it gets really shallow, and then there's another kind of open water area, and then it gets real shallow again, and it doesn't connect back over. So we had looked at trying to connect that same path out this way and take advantage of that open water channel or open water area here. And that alternative obviously is going to create more wetland impacts. That comes at a cost. But we can offset that cost in the project by reducing the volume of material that we take out of the big lake in the deeper parts of the lake. So that was the compromise. So what I've wanted to do was bring forward 3 different alternatives. I don't expect that the town is likely going to want to move forward with any one of these as I have them presented. But I wanted to kind of give you your options. And from that, you can then see, well, if I move in the direction towards all the sediment, this is the direction I'm going, and now I'm going to have to figure out how to come up with more money. If I move in the direction of trying to preserve all the wetlands, we've got that. If I move in the direction of kind of compromise, how do I create more recreational area, try and bring back some of the things that were brought up in the Upper Colisaja River report that was done 2004 time period, trying to maximize those historic recreational benefits that were provided from the lake, then this does this. And it also gives us a little bit of viability on trying to adjust the dredge volumes based on the pricing that we're getting. So with that, we'll talk about this next slide. Our recommendations. From our perspective, based on what we know about the information we've been provided from the town administration and the prior reports that I've seen, the focus that's been brought forward on phase 1, we felt like the option that best addressed all of the different initiatives and strategies that were emphasized was the option 2A. It also gives you the most flexibility because not only does it allow us to go in and try and maximize recreation and adjust dredge quantity to be able to accommodate the additional cost of the wetland impacts, but it also allows us the ability to go in and set up bid alternates, which is another recommendation that I have for this project. Even if we're moving forward with a phase 2 and then a phase 3, right now we're recommending phase 2 is the open water lake portion. And because that's the easiest one to permit, we get permits first, we get that underway. Then we move towards the phase 3, which is the River Reach section and the Mill Creek section. That's where most of our wetland impacts are. That's where most of our problems are going to be as far as turbidity and other issues the agencies are going to be concerned with. And that's the one that's likely going to be a 9-month process for permitting. But it allows us to go through, kind of run both of them in parallel to a point of getting the permit submitted. One comes out early, we bid it, we get it out to work. The other one continues to work its way through the process of permitting. And then 4 months, 5 months, 6 months later, whenever we get it out of permit, we can bid that one, or we can hold off on it. If the town's got too much going already, let that phase 2 move out and be finished, and then bid phase 3. Gives you different options. And then in phase 2 and phase 3, it gives us the ability to do bid alternatives based on total quantity. So we could make the wetland, if we chose the Mill Creek wetland area and that secondary channel, that could be a bid alternative. Talk a little bit about bid alternatives. What we do with the bid process in public bidding is we'll identify the minimum work that needs to be done. We'll ask the contractor to give us a price for that work. And then it will put in a bid alternative, which is a description of additional work that we want the contractor to do and give us a price on. But there's no guarantee that the town will authorize that second alternative or that third alternative. They'll wait until they get bids in, a low bidder is selected, and then they will have the option of, with that apparent low bidder that they want to award to, they'll say, we want to do the base contract, plus we want to do alternative 1 or alternative 2, because then you've got all the numbers in front of you and you know what you can afford. So if we do that with phase 1, or phase 2, and we do that with phase 3, I think it gives the most flexibility to the town, especially in this environment that we're dealing with right now with construction pricing being very volatile. We go on to the next slide, please. This was something I didn't put in the report, but we have looked at a schedule for all of this and how this all plays out. So we're expecting, if we move through, the town gives us approval to move out into design and permitting in the next 30 days. Then we could be looking at getting the phase 2 design underway in April. We could be ready to bid that project based on our assumptions right now as early as September of this year. I think that works out fairly well with phase 1. My understanding is phase 1, where it is now, getting started in March, probably is going to end up being done in June or July, is what I would estimate. And you may have a better date than I do for that. But then allows you to come in, basically button all that up, finish out all the work with phase 1. Contractor can remove all of their materials and all their equipment. You can go out and you can do a new bid and do bidding on September. That puts us under construction by December of this year on phase 2. Then go to the next slide, please. So then this is the end of that construction period here. This is where phase 3 comes in, running in parallel up front on the design, but having a longer permitting period pushes the rest of the project out. So we end up with bidding in February, we end up with construction in April of next year, and we end up with completion of construction near the fall of 26. So again, it allows the town to have a little bit of a break between phase 1, phase 2, phase 3. It allows you to manage this. If you're finding that you're having problems or delays associated with the construction due to weather or other things that were unanticipated in phase 2, you can push phase 3 out and choose not to do it. If you find that phase 2 costs too much money and you don't have the money available to do phase 3, then you can choose to delay phase 3 to a later time when you've had additional funding come available. So one of the things we're trying to do all the way through this dredge plan is come up with options for the town, recognizing that if you find a single path and you get on that one path, something's in construction, something always goes wrong. It never happens exactly as you anticipate it will. So we want to try and find off-ramps in different locations through the schedule, through the bidding, through the alternates process. Last slide. So future considerations. This wasn't part of the report, but I think it is important for the town to consider, the Lake Association to consider long-term. There are things that were recommended in prior studies. The drainage plan for the town, implementing sedimentation basins, try and reduce the volume of materials that are moved downstream and deposited in the Mill Creek wetland area. The management of the golf courses and the different areas that contribute sediments in the upper Colasaja. All of those things take time and take the cooperation of other parties to achieve. So long-term, are you going to be able to achieve all of the things that you'd like to do, all the strategies and action plans that were put forth in that study that was done? It's highly likely that even if you are able to do it, it's going to take a long time to get it implemented. So coming up with a maintenance dredge plan that you work on today and through the time that you're doing this dredge program now would put you in a better position to look at 5 years down the road, 10 years down the road, being able to come back in and have a self-funded dredging program. Lots of details on how that gets done and who pays for it and all that. But from an engineering perspective, I recommend that you don't go through this process again, which is you're looking at sediment accumulation that's happened since the 1930s when it was first built. You're trying to address it all at one time. It's much easier to eat the elephant one piece at a time, one bite at a time, than it is to try and come in and tackle it all at one time. Right now, we're talking a little big money and huge operations and things that are going to take a fairly long time and have impacts to all the residents in the area for all that time. And all that's necessary to accomplish getting it back to at least the point where everybody wants it to be, to offer the benefits that it does to the community. If you don't want to do that again, come up with a dredge plan, look at ways of funding it long-term, look at ways of managing it long-term, and look at ways to try and enhance the ability to cooperate with the upstream contributors and have them continue to try and improve their efforts at reducing the amount of dredge material that you have to contend with 10 years from now, or whenever you come about doing this again. So, and with that, I think that is the last slide, and I will open it to questions.
Okay. Let me ask one question first. The Mill Creek wetland area,
Yes, sir.
I'll just be real candid and frank. A lot of people that around that area feel like we've left them out and that maybe we didn't raise enough money and so forth. If we were to go back and try to get that reversed as a wetland and dredge that, what kind of money you think we're talking about?
The whole thing.
Yeah,
If
that's what these folks want.
I'm trying to think of the total area of that wetland, I think is in excess of 5 acres. So if we did a dredge of the entire thing, assuming that it's all going to be considered 1-to-1 mitigation, and I can't say that for sure, once we get into doing wholesale removal of an existing wetland system, I would expect a range that's going to be in the, probably in the, I said before the value was 70, I think 75, 76,000.
Yeah.
Yeah.
Right.
So then we're looking at $350,000 using the 1-to-1, and it likely is, there's when you get into larger areas where you're taking out an entire wetland habitat, the agencies have a tendency to up the scale. So we may end up with something as great as, say, 700,000 if they went to a 2-to-1 on the entire area.
But that's just mitigation.
Yeah, we want to know.
That's the cost of mitigation. That's not the cost of of
Of
doing
dredging.
the dredging.
Yeah. How
That's
much,
the cost of mitigation.
what do you think? Are we talking about 5 million, 10 million? What
If
do you
we
think?
focused on that area alone and didn't do anything else, we may have enough in the 5 million to do that with the mitigation, with the dredge, with the other
You
things
mean
that come into
5 million
consideration.
more?
I think it's hard for me to run out numbers in my head right now, but
Right.
I would say it'd be probably in excess of 3 million. Just to handle that additional volume of material
To 4 feet of depth.
to 4 feet of depth.
Seems like it'd be more
Because
than that.
we're talking about 5-6 acres to 4 feet of depth. That's a fairly large volume of material.
Might I say something? I tried to do some math here and trying to figure out what a cubic yard would cover in 500 cubic yards. I think it takes 400 cubic yards to take a football field, not including the end zones, to a depth of 27 inches. Is my math wrong on that? Because that's what $5 million is buying us. I mean, 500,000 that we were able to raise is buying us. And by the way, there was no donations that I'm aware of that came from this Mill Creek area. The 60% of our money came from 2 donors. 70% came from 4 donors. And we had altogether 45 people in this entire town who contributed a dime to our Mirror Lake efforts to do something with our $500,000. So I'm really trying to be very respectful to those 2 that gave the 60% of the money, and they do not live in that area. In fact, neither one of them lives on the lake, but they're great citizens, and I think they need to be respected. And I think that I look at Mirror Lake area, the old lake, as a beautiful wetland, and I'd like to see trout in the river, but that's where I'm at. So, and
Working with John Bryant historically, he always came up with a figure that, if I recall, it was somewhere between $100 and $125 per cubic yard of material removed. So you can kind of figure it out that way.
Yeah, and so as a comparison, because I had those conversations with John Bryant about the cost that he was dealing with for phase 1, and recognize he's doing it on a much smaller scale, and he's dealing with it over a longer period of time. If we came in with these operations at this bigger scale, we'd likely see the cost per yard come down. But would it come from 120 down to 75 or 65? Our guess is that it's likely going to be in that kind of 75 to 80,000 dollars per cubic yard range on this larger project, compared to the higher value that they have in phase 1 because of the way that they approach phase 1.
yeah, I can't remember what their exact quote was.
Mike, as you
It's a lot
answered
more
my
than-
question, it clicked on me. Reversing the wetland, that's the 700 something thousand dollars you would think that would have to be paid just to break the designation as a wetland, where the state or someone could buy wetlands from somewhere
Correct.
else in the.
Yeah, and I would say right now, I'd certainly put it in a range of likely 350 to maybe as much as 700,000, just for the permitting aspect, the mitigation aspect of the wetland.
Are
And
those
then we've
called-
got the material that we need to deal with as far as dredging.
Those called mitigation credits.
Yes, sir.
You buy
Yes,
those
you're-
mitigation
Yes,
credits.
you're buying mitigation
Gotcha.
credits. Yes, sir.
Yeah.
What I've noticed is nobody has title to the Mirror Lake, the old Mill Creek area. Nobody has title to that whole area. Could the town take an eminent domain over that and then agree to preserve that area as a wetland and get credits for all of that area? In other words, could we take credit and then just declare it, we're going to preserve this as a wetland forever, and take that money, that credit we get, and use it toward preserving everything else?
It gets a little complicated in the fact that it's not an isolated wetland. It's part of the run of the river. Mill Creek flows through the wetland. It's connected to the upper Colasaja River. So it's not an isolated wetland that sits out by itself. And when you start getting into wetlands, trying to do preservation and conservation of wetlands, it's typically easier to do it with wetlands that can be isolated and aren't part of the run of the river of a state water.
Well, didn't Stafford was the name of the recent Supreme Court case? Is that the name of that case that came out that said that really challenged that whole premise about being adjoining state waters? I mean, didn't that case say that about a year ago, June or so?
Yeah, that was certainly part of it. There were a lot of different things that were involved in that case. As far as I understand it, and I'm not the environmental specialist on this. We have other folks in my firm that do this for us. But my understanding, if you have a wetland that is part of a contiguous water body that is a water of the state, it becomes difficult to isolate that water as part of a preservation and therefore credit scenario. So that's been my experience in the past. I know I've tried it on other projects, but it's been several years ago when we run across those issues with the agencies, and we weren't able to do it because of that very reason. Did Stafford change that? I don't think so, but I can certainly look into it and provide you more information if you'd like me to do that.
Curious. Yeah, I knew you knew a lot more than I just threw that out to see if it.
Okay, go ahead.
Just as a clarification, an acre foot is 1,608 yards. Take the Mill Creek area, if it's 5 acres, it would be 8,000 yards for 1 foot.
Right. So go by that.
When you go the valley, is
Yes.
$78,000 per acre. Is that per acre foot or per acre?
That's per cubic yard.
Per cubic yard.
Yes, sir.
So what is it? Run that line with you.
So it's right now,
It says $80,000, so that's what it was. 1,600 acres.
no, that's per cubic yard.
Yeah, minute.
So you have to look at the acre feet, convert that into cubic yards.
An acre foot is 1,608 cubic yards.
Okay. So then 1,608, and then you're saying that's 1 foot of depth over the 6 acre area. Okay. So then we go to 4 feet of depth, which is what we were looking at for open water. So now we're at, rough math, 80, no, 1,600 going to 4.
32,000.
I'm not ready to do math tonight.
That's feet.
Yeah,
The last number that you provided was a 16,000,
I didn't.
1,600, I'm sorry.
okay.
All I said was an acre foot is
1,600 cubic yards. Right. So if I'm taking 1,600 cubic yards, I'm multiplying that times 4.
Times 8, then 4,
Right. That's where the,
or however many.
I apologize.
so but what I would
On the
suggest,
Spot here.
rather than us try and do mental gymnastics today,
Yeah,
if you want to ask me that question, I'll be more than glad to give you that answer when I'm not standing up here.
sure, that'll be fine.
So give me the time to run the numbers. I'm more than glad to provide the information.
Okay, good.
my next comment was whoever any have to communicate all about this project. Because I know there's quite a few people very interested in it. And in fact,
With what was the question?
was there any effort to communicate with the public?
Oh, okay.
My answer is yes.
That's what this is.
There's been, we covered this at the board meetings. There's been meetings of the Mirror Lake Association. My office has been open, Jim, and, yes, we're not trying to cover anything up. We're moving forward with this.
That's the reason for this meeting.
Yes,
Well, I know you received some information.
yes, we did.
Address that.
Yes, we did. We did. And like I say, this meeting was open. I've attended meetings before with the Home Improvement Association. There's no closeted agenda here. We're trying to do the best we can with the money that we were able to acquire from the state. And it's going to be some very difficult decisions that have to be made on how do we go, where do we proceed, and so forth. I will invite, though, this. the opportunity to get more state funding, especially in light of Helene, is nil. That's not going to happen. If there are people in the community, as Mike has said, that were generous and everything, and they would like to see more done than what we're limited with the money we have now, I would certainly welcome them to be able to contribute and help us move even further than what we're planning now.
So here's a big idea. Well, first, let me ask a couple questions, then I'll give you my big idea. First of all, great job. I love this because in some ways it's a very close parallel to what we originally came up with 4 or 5 years ago in terms of its scope and the areas and the impact. So I applaud you guys for putting it together so professionally. I'm curious about one thing. I know you guys were out there a lot pre-hurricane and then post-hurricane. Any idea how much more impact the hurricane gave the project? I mean, did it double the sediment? Was it 10% more? Can you speak to that at all?
I really can't, unfortunately.
Okay.
The way that things came about, we had done most of our riverine and open lake sediment survey prior to Helene happening. When we were back out there again after Helene, we ended up doing the Mill Creek wetland and some additional cross sections that we had missed when we were trying to finish up just before Helene.
Okay.
And our folks pulled out of here the day Helene was hitting. I was on the phone telling them to load the boat and
I saw them doing it.
Yeah.
So, we tried to stay out here as long as we could to try and get things done. We weren't able to finish before Helene. And being that most of the work was already done, we didn't go back in and try and redo that sediment survey at that time.
Very good.
I would like to, if you don't mind, you talked about maintenance in the future. Have you at all identified a location where Mill Creek could be captured, or at least a settling point arranged where the water that comes from the town would settle down before it gets to the lake, and where it could also be easily removed, like at the bottom of Bruner and Colasaja, that's one that comes right under the road. Shortly after that, could it be, have y'all considered a depth area there where you could retain the water to let the sediment drop and have it near where a bucket, a digger could get in there and get it out?
So that speaks to I think some of the strategies and action plan that came from the prior report. There was a lot of focus on trying to implement things just like that. It was not part of our scope. When we were brought in, we were asked to figure out a dredge plan.
Well, if you were
How far
asked,
can we go with $5 million?
but when you do your bidding, when you ask for a bid, could you not simply say ask them what would they charge to create these sediment areas?
So what I was going to add on was that is certainly something that if you want us to add that to our design as we move forward. So right now we're delivering the preliminary engineering report that basically trying to put everything in a bucket and say, this is how much you can do. And through your deliberations, when you come back and say, we want to do this, that, and this, and we think all of that's going to fit in that same bucket, you want to tell me to put in a sedimentation basin right at the mouth of where Mill Creek empties into that wetland. We can certainly do it. And what I would say is I haven't looked at any of the areas that were upstream from that area. But if I were looking at limiting the work that I'm doing to the area of the lake and that Mill Creek wetland, right at the outfall of where that river comes in, or the stream comes into the river at that location would be an excellent location to put in a sedimentation basin. And that's certainly something that can be done. We certainly have a lot of experience in designing those for other types of applications. So that's up to you all to determine if you want to reach back and grab a hold of one of the strategies that was brought forward from that other report and say, we want to do that in part of this project, we can do that.
I was looking for an expert to tell us that if you want sediment collections, that these are the locations that we would recommend that you put them, not that we would recommend them to you because.
No, I'm saying if you wanted us to incorporate a sedimentation basin, you're not dictating to us where to put it.
Okay.
You're saying, give us one.
So you identified at the curve of the lake, where
Right.
the river meets the body of the
Mhm.
lake, you said there was a collection point for sediment. So with that, I mean, that's where the islands are developing and everything else. So that would be a place you would make extra deep if you could do it with the utilities in place there?
So can you go backwards to the slide that,
No.
I bet you can.
I would say you could go as far back as Harris Lake, like,
Yeah.
or even maybe farther.
Continue. A little more. I wanted to get stop right, no, that one. So this gives us the entire reach from the upper end, where we're stopping the dredging, the riverine section, all the way down to the dam at the bottom end. Just off the top of my head, if I were looking for locations to try and stop sediments from further accumulating into these water bodies, one obvious location would be right here at the mouth of Mill Creek. That's a great location for us to try and capture that sediment before it goes out into the wetland. And if we go in and we spend money to try and remove this wetland and make it open water, then the last thing you want to do is leave it open to allow sediment to accumulate in the future. And recognizing, as I said before, the work that's being done in the upper watershed may take years to implement, and you may have a sediment load coming in, even if it's diminishing over time, there may be a sediment load that's continuing to come into this water body for the next 10, 15, 20 years. You want to try and manage that as best you can. That would be a good place to put it. We also talked about looking in these areas, in the open water area. I identified this area here. This is another tributary that comes in right here. That's an unnamed tributary. That would be a good location to put in a small sedimentation basin. It wouldn't have to be anywhere near the size of this one because of the drainage area is much smaller. Another location would be, there's a tributary that comes in right here. Trying to put in some type of a sedimentation basin right here would be another good opportunity. That would also potentially allow us to try and capture and trap some of the material that's coming down from the upper watershed if we put in some type of a sedimentation basin in this area, because it would serve a dual purpose. And you also want to make sure that the sedimentation basins, if you do put them in, you want to put them in a place that's easy to access.
Yeah, exactly.
So you got to have an open area, a flat land that you can bring in a track hoe or a backhoe, depending on the size of the sedimentation basin, to be able to remove that sediment on a regular basis. And then, yes, I would recommend, if you go in that direction, that you look at not only creating the sedimentation basins, but as part of your maintenance plan, you look at either regularly hiring every 2 years, 3 years, and we can certainly make recommendations if you want to go in that direction as far as how frequently to do it, to have that done, or to expand your own operations to be able to do it with your own staff. It's not a lot of additional material or a lot of additional equipment or manpower that it would take to do that. It would be a matter of going in and making it a priority as part of your budgeting process over the next several years to try and find the funds to do that. And that's going to be the challenge of doing any of that type of implementation of sedimentation basins. It's just like creating a stormwater treatment device and scatter them all over the city. They're great things to have, but now I have to maintain them. And if you don't have a maintenance plan, they will fill up and they will be ineffective very quickly. Yes, sir.
Go ahead.
Good question. Here, like, phase one, it's right here at the bridge.
Yes, essentially this little lobe right here and this little lobe right here.
Phase three, you're up into the river.
Correct. We'd be picking up, so one of the things that's about phase one, the depth that phase one is going in both of these two areas is very limited. I would expect on the upstream side, because of the existing utilities, we're likely not going to be able to go much deeper than what phase one is already doing. On the downstream side, we could likely go deeper. And that'll be another decision that the town has to make is, do we want to go ahead and go back into that piece of phase one and take it down deeper? Or we want to leave phase one where it is? Right now, phase one, based on the discussions I've had with John, indicated that they're looking at somewhere around 1 to 2 feet of sediment removal. As we talked about before, we're talking, depending on what option we look at, anywhere from, 1 to 2 feet in certain areas to as much as 10 or 12 feet in certain areas. So that's something to look at. But then from here up, all of this area here, predominantly limited to, if we go full dredge, 4 feet is the amount of material that will likely move on average for this entire reach.
My question is, if we're gonna spend this money now, doing phase one, and you're gonna be upstream on phase three, are we then in danger of the turbidity which you're creating above it, of covering everything?
Turbidity is now set.
So I would say that that's not a high likelihood. Certainly it can happen if things that are unanticipated occur during construction. So the way that you would manage this construction going on in this riverine section, right now, our report talked about kind of a hybrid approach, utilizing basically a hydraulic dredge that's then put on a machine that allows it to walk across land. So it basically an amphibious type machine. That's one way of dealing with it. Another way would be to bring in the more traditional track hoe on a barge and another barge over here to deposit the material and work your way up the channel that way. That's typically mechanical dredging. That's the one that disturbs the most material and is hardest to control in turbidity. And one of the reasons why we were recommending not moving in that direction is because that takes more time. Generally, you want to dewater the area before you do that type of dredging. You don't want to have a lot of material. The more water that you're pulling that material up through, the more possibility you have for turbidity. So if you can drop the water elevation, you can move your way through that more like a mining operation than a dredging operation. And then time is not as much of an issue. But obviously dewatering all these perimeter wetlands along here for the duration of time that you're going to be working on that project potentially has some impact there. The biggest issue is that work should be controlled based on the work based on what we put together in the specifications. We won't be dictating through the specifications how they do it. We'll be dictating the performance. So we'll be telling them the quantity of material they have to remove, and we'll tell them the conditions under which they have to try and achieve removal of that material. So that will limit the amount of turbidity they're allowed to have. And there'll be testing that will be verifying that turbidity limit. And they will be implementing turbidity curtains and other types of methods to try and reduce that. So I don't expect that in a normal operation, we'd end up with a large sediment plume down here during phase three. However, as is the course, we're working in a river. We end up with another Helene or anything close to it at the middle of the operations. We could have a washout that could certainly move a lot of sediment downstream unintended. And the contractor would have no way of controlling that force majeure, power of nature. So there's always a possibility that could happen. We will do what we can through the permitting and through the specifications to try and limit that and minimize that possibility.
So I never got to my big idea.
Yes, sir.
If I'm running numbers on this deal to get everything we want, we need money, more money. So, and Pat's already said, good luck going back to the state for more money. So here's my deal. We got to pay you guys, right? So that leaves us with a sum. You've made some recommendations which aren't met with the remaining money, especially if we're now hiring, what'd you call it, a general contractor over the whole deal? Or
Construction manager.
Construction manager.
Yes.
So have you ever seen this happen where something like this starts and then we go into serious fundraising mode because it starts. Because I'll be honest with you, we've got a lot of people sitting on their hands who aren't going to give a dime until they see some action.
Mhm.
Okay?
Show me.
Yeah. And the other thing is, there's been some talk about HOAs and whatever, but if there's 200 homes in the that kind of call Mirror Lake theirs, if they were asked to join an association that's dedicated to the dredging effort and thereby asked to donate $1,000 a year, that's $200,000 a year. And in the course of 2 years or 3 years or however many years, we've got money to not only make up the shortfall, but to also maintain
Yes.
the watershed.
And that was.
Have you ever seen that happen?
Certainly I have. I've seen for the purposes of setting up basically, the way that you're doing that is this basically it's a special assessment district. That is a recognized governmental entity within North Carolina. And there are ways to go about doing that that would allow you to do that legally and provide direction on how the funds are to be utilized, because it would limit the funds that were collected to be utilized only for the specific purpose that that district was established. I've not seen one done for dredging, but I certainly have seen one done for maintenance operations, whether it be maintenance on a lake or maintenance operations on a subdivision. That's essentially what an HOA fee
Right.
is,
Right.
is a special assessment district. So that is what I alluded to earlier when I said, moving down the pathway of doing a long-term dredge maintenance plan. There are various ways to implement that, and that's certainly one of them, and probably one of the more popular ones as far as the way to generate revenue, not just one time, but have it generate over a lengthy period of time to be able to allow continued operations.
Okay.
We're in a double bind, and here's the double binding. Pat just alluded to it. People say, "What? We want to see some action," and I've been hearing now for months. What's going on? Nothing's going on. Y'all aren't doing the dredging. They didn't understand things were going on, but it takes time. Now, you're looking for direction. Some folks might say, "Well, you're moving too fast," but if we don't move fast, if we say, "Oh, we're going to take another 4 months to get more input and talk about this," that phase two, that seems to me is the next step. We're just pushing everything down the road. Slow walking. So what you are looking for, some guidance, do we move on phase two, which is easily permitted or faster permitted and, and so forth? Or do we kind of ponder this and make a decision at a later date?
I'm for moving forward, but I still have a question. If
Okay,
you'd like, if you allow. me
go
to
for
ask.
it.
Okay, I noticed that your testing sites didn't actually include any of that Mill Creek area.
Correct.
Okay, so I'm wondering, because that is the drainage and most of that has come from the town, the part that from our stormwater, from what's happened from our oils and greases and everything and tires and everything else that has happened on a basically built upon area, as opposed to Upper Calisaja, which is houses, but doesn't have nearly the impervious surface, okay? I'm just kind of wondering if that sediment is actually, can we just say, oh yeah, that's the same as everything else, and so we can put it wherever we want to? Because you were talking about initially, getting rid of it is, it's sometimes difficult because of what is in the sediment.
Correct. So what we did when we set up our sampling sites was to try and get what we felt was a fairly good sample across the entire length of the area that we were going to be working
I'm
on.
not questioning
No,
that, I'm
and-
just saying,
yeah,
if
no,
we
and-
went to
Right.
dredging and doing that, seems to me, we need to know what that sediment looks like.
And I would say that if we are looking at doing something more than what was originally anticipated in our report, if we're looking at putting a sedimentation basin, if we're looking at doing a complete removal of the entire wetland and bringing it down to 4 feet, then I would agree with you. We probably do need to do additional testing there because the testing that we have may or may not be representative of what's there. That's certainly something that we can do while we're working our way through the implementation of phase 2 and working our way through the permitting of phase 3. We could do the additional testing as part of that design process and see whether or not it turns up anything that's out of the ordinary based on what we already have. And based on those results, we can determine whether or not we need to come up with an alternate plan for that specific area.
Because when I look at, one is it's at the dam, 2 is
Mhm.
basically at the bridge, 3 is above the bridge, and then
Yep.
4 is all the way up at basically where you started,
Correct.
you know, the thing. And 1 and 2 are the ones that are much more heavily impacted, have more stuff in them
Mhm.
than 3 and 4. So what is coming from above the bridge or above, let's say, Mill Creek and below Mill Creek that's where it's coming from.
And
Just looking at the numbers that you have right now,
As-
anticipating where it could be coming from, because Mill Creek is what drains
The good news
the
is
impervious
that we-
surface of Highlands.
yeah, the good news is we didn't find a lot of material in the open water lake area that would suggest that there is something more. But that could also mean that it's being trapped in the wetland
That's
and
what
not
I'm
making
saying.
it to the
Wetlands
lake.
are great for trapping that
right.
stuff.
So
I'm not sure that I
I'm-
want to get rid of it.
Yeah, no, I'm on board with you in the fact that the wetland is serving a function. Is it serving the function that the residents want it to serve at this time? That's another question. But yes, it certainly does serve a function. And right now, that function is removing a lot of the potential pollutant load from getting into the lake. It is acting as a sediment basin, the entire wetland is.
Well, and because our grant was based on water quality, not recreation, not property values, not those kinds of things that people would want because they want lakefront property. That's actually beneficial to us to have that continue to be that basically sediment basin there that's capturing all that stuff because we're drinking that stuff. Further down the road, we're drinking that stuff. Anyway, just a point I wanted to make that I don't think we should just go ahead and dredge the Mill Creek area without knowing what we're dredging.
Absolutely. I think it would be prudent to understand more about it before we make a specific decision in that direction.
Okay. Any other questions?
Just one quick comment. If you spend $1 million on dredging, what's the percentage of it that goes towards transportation in a typical stuff?
Most of it.
Depends how far you gotta take it.
Yeah.
Yeah, no, but is it?
I mean, what I can say is the reason why we spent an additional amount of time during this preliminary engineering phase to try and verify that the old Highlands landfill could actually be used for disposal, even if it was only a portion of the volume, was that it's a significant value.
Yeah, the reason I asked is I would guess if a normal job is 50%, I'll bet we're way over 50%.
Yeah, I'd have to look at how the numbers actually play out. Trying to go back and think about all the different things that we've run, and how they played out in the different options. My guess is that in the larger volume of material, the option 1, I think it was above a third of the total value was associated. Don't remember offhand, but I'm thinking it was in the range of $2 to $3 million.
And there's no way to take the sediment back to where it came from, like Highlands Falls Country Club, River Walk.
Load it on a plane and do airdrops.
Can't we just give it back to them?
Well, we joke about that, but I did look at other alternatives for sediment disposal because the haul it away is always going to be the more expensive option. Some of the other types of methods that you would look at typically would be, can you dispose of it in place? Can we isolate a specific area and create a berm with the sediment and then dump more sediment in that area and basically create a land mass that is sediment?
We talked to John Bryan about doing that
Yeah.
at the wetland.
And it's difficult for a variety of reasons on this project. One is we don't have a lot of open water to deal with.
Yeah.
We're dealing with an upper section that's primarily riverine, very narrow, 30 to 50 feet wide at best through a lot of the areas, and less in certain areas due to wetlands. And then as we go in the open water area of the lake, find somebody who wants to give up their lakefront footage to put a sediment island in.
Right.
It's always a challenge. So we did consider it. We set it aside because we didn't feel like it was an appropriate option here. That option is better suited for offshore dredging, where you can identify an area that's currently not utilized and create an island or something like that long-term.
Correct me if I'm wrong. you
Not
guys.
well
Didn't-
suited for this.
Didn't they do that at Big Creek? Didn't they?
They did, yeah,
created
but that was like experimental dredging from what I
Okay,
understand, like some
that was
homeowners
Matthew,
hired
yeah.
some guy and
Yeah, we didn't do it.
the town didn't do it.
I will say this too. I know people say this was caused by this or that. I'll tell you what we have to be aware of. We live in a subtropical rainforest with highly distressed hills and mountains.
Steep slopes.
And we get over
And our
100
soil is
inches
very
of
rough.
rain a year, and nothing was done for over 70-something years.
Yep,
So what else do we expect?
exactly.
Sedimentation. So, what's the pleasure of the board? And I know these guys are looking for any kind of direction
You
tonight.
can't pinpoint any one source of it.
I'd rather have a little bit of time. I mean,
I want to
Okay.
think about it.
Okay,
me too, now that I understand it better.
okay, that'll be fine.
No, we got to have an answer today.
We'll
Yes.
get back with you and y'all be available for questions further.
By all means, let us know. And if we need to come back up to have another session, we'll be glad to do that too. I know that you've got a lot to chew on, a lot of decisions and different things to weigh out. And we're more than glad to have, whatever additional conversation you need to have in order to reach those decisions.
One question, your contract is for how much?
700 and some plus.
700 and some,
Well, that was the original one that included the construction management, and then that was pulled out. That was the initial authorization. So I think,
out.
Yeah.
Construction
so
plan.
those, but that, with the management be about $700,000 or $800,000 for engineering and management?
Mhm.
And would that, is that going to be, depending on what we do, like if we decided to go in and do more permitting than we, like into the Mirror Lake, into the Mill Creek area, that additional cost, is that going to, does that, in other words, there's something in your contract that could make that number go up?
as of right now, what we're under contract to do is the design through bidding. And then we come back to do construction administration, moving forward. And part of that was at your request. And also, I think that's prudent because we don't know what we're constructing yet. And the value of that could vary. What we have right now is fixed. Unless you tell us to go outside of the area that you told us originally to work in.
Okay.
You're paying for what you're getting out of this. You choose option 1 or option 2A, it doesn't cost you more.
But those options, we have then $4,200,000 roughly
Right.
from
to
the
work
5
with.
million.
Mhm.
So we need to get busy raising some money to meet any of those.
Or look at the alternatives that I mentioned earlier
Less
to
depth.
try and reduce the amount of dredging. And certainly it's one way or the other. Either you pull down the dredging quantity that you want to achieve
Right.
to try and meet the amount of money you have, or you raise more money to try and meet the amount of dredging that you want to achieve.
Well, there's
Or
my
amount of
concern
wetland
is that
impact that you want to achieve, however.
when
want
you
to put
said
that.
along the banks of the main body of the lake, there are these little grasses and stuff that you would not touch because you called them wetlands.
So, yes.
And I would call them, any owner that wanted to go down and get knee deep in the water could pull those babies out, right?
So any owner that goes down and starts doing that is not a licensed engineer who has to stipulate to
Oh,
the
okay, okay.
requirements of the state permitting agencies or the federal permitting agencies regarding wetlands. And whatever risk they want to take at potentially being called upon because they were doing that is up to them. Our job is to tell you, these are jurisdictional, and therefore there is something that needs to be done to offset or mitigate impact.
Jurisdictional based on your interpretation of the Stafford decision, is that, because that, I'm not sure that, if it's growing off
So
my,
those wetlands were outlined not by me, but our environmental scientists who are up to par on what all of the current regs are and what's considered a wetland, what's not regarding both Army Corps and DEQ. And when we go out and do a wetland designation, we're not the ones who have the final say. The agencies come in and review what we've done, and they say, yes, that's a wetland, no, that's not a wetland. So the ultimate call is on the agency, not on us. We're just giving you our best professional opinion to try and anticipate what the cost is going to be when we impact it,
thank you.
or if you choose to impact.
But the Corps has designated wetlands where you should, right?
As far as Corps has not come out to do the designations. We're in the preliminary stages. We wouldn't have the Corps come out and do designations until such time as we have direction from you on what it is we need to do. And then we move forward with design. As part of that design, we'll submit documentation to the Corps and to DEQ saying, these are the wetland impacts we expect we're going to have. At that time, they'll come out and do the jurisdictional verification.
Yeah.
Thank you.
Thanks.
I just had one question, it's a strange question. Initially, you said historically, Mirror Lake was dredged? Or is
No.
it just dammed and backed up?
Dammed and backed up.
Okay.
Yeah, to my
I thought you
knowledge-
said something about
Yeah.
it was way, way deep and I, you
No,
know.
to
and I
my
thought,
knowledge,
My God,
if
I didn't know it was ever dredged.
yeah, no, to my knowledge, it has not been dredged.
Yeah, it's just.
We
dammed
didn't
back
find
up.
any information in our research of available data that suggested that it had been maintained or dredged in the past. It was somewhat difficult to find when the dam was actually installed. But we feel comfortable saying it's likely sometime after Sequoia, likely something like 10 or 15 years after Sequoia was dammed up.
I've always heard about 1948,
48?
49.
Do you know the very first dam in Highlands? It's the one at the biological station.
What year?
I don't know, but it's on the 1909
Randy Shepard
topo
said
maps.
that dam was put in place as a wooden dam in 1927.
Which
No.
one?
The Mirror Lake Dam.
Yeah.
And that's to facilitate with the mill work down there at the end of the dam. They had a mill shop.
Did it?
But then that
Is
dam
it in
got
there?
washed out and somebody can place it.
Okay.
Nobody knows who made that concrete thing.
Yeah.
Okay. All right. Any, don't want to cut anybody short. Any other questions from anywhere? Hearing none, I would entertain, and I appreciate y'all coming and answering all the questions
Thank
for
you,
us
guys.
tonight. And we'll be getting back with you.
All right.
And also, anyone who is, listening to this broadcast, if you want to, ask any questions that we can pass on, you can send them to, mayor@highlandsnc.org. And I'll be happy to pass those on. Hearing no further discussion, do I have a motion to adjourn? All in favor? We're adjourned. Thank you.
Right.
Yeah.
Okay. And your contact information. Good. Rather than need every 3 to 4 days.
What's his deal?